Hi, welcome back to College Algebra. This is week 3. We're going to cover 1.7, 2.1, and 2.2 this week. We'll cover absolute value inequalities, linear equation in two variables, and slope and rate of change. Again, please look over this list of measurable outcomes. So previously we studied absolute value equation. In this section we're going to cover absolute value inequalities. Inequality of the form absolute value of x is less than a, less than equal to a, greater than a, greater than equal to a. Those are called absolute value inequalities. We saw earlier that absolute value of x equal to 3 means that x is either 3 or negative 3. And so we get two solutions, 3 and negative 3. And we saw the absolute value represent distance. And in this case, it represents distance of x from 0. And so there's 2 points whose distance from 0 is 3. And those points are negative 3 and positive 3. If I look at absolute value of x is greater than 3, that means that we're looking for points whose distance from 0 is greater than 3. So that means that you have to be from 3 or more, or from negative 3 or less, because these are the points whose distance from 0 is greater than 3. So that means the absolute value of x being greater than 3 means that either x is less than negative 3 or x is greater than positive 3. And on the other hand, if you have absolute value of x is less than 3, that means that we want a set of all points whose distance from 0 is 3 or less. That means that we are between negative 3 and positive 3. Or if you have the absolute value of x is less than 3, that means that x must be bigger than negative 3 and less than 3. And less than 3, that's right. And so this is how we want to summarize the absolute value equations and inequalities. If absolute value of x is a, then x is negative a or positive a. If the absolute value of x is greater than a, that means x is less than negative a or x is greater than positive a. So we are either less than negative a or bigger than positive a. And if the absolute value of x is less than a, that means we are between negative a and positive a. So we have to memorize those three cases. So how do we solve this? We always want to isolate absolute value. So we're going to bring the 4 over to make the 11. So now we have the absolute value inequality. We can use those cases we saw earlier of this form. Absolute value x is less than a. So that means that 3w plus 1 has to be bigger than negative 1 and less than bigger than negative 11 and less than 11. So this is the one of those three cases. So if I solve for w, then I get w is bigger than negative 4 and less than 10 over 3. So that means we have this interval. Same thing here, we want to isolate the absolute value, so we're going to subtract 1 from both sides, and then we have that, let's see, okay, I guess in this case we can, just to make things a little bit simpler, the book chose to kind of switch the inequality, switch the two expressions so that the 3 is on this side and this is on this side, and at the same time switching the inequality. It's the same inequality except that we just switching the order so that the absolute value is on the left side, because that's how we're used to set up our three cases. And so if I solve for absolute value of x here, then I get that absolute value of 1/2 t minus 5 is bigger than or equal to 2. So this is the expression of this form. So that means we have two cases. Either 1/2 t minus 5, the inside expression, is less than or equal to negative 2, or it is greater than or equal to positive 2. So solving for each of them individually, we have that t is either less than or equal to 6, or t is greater than or equal to 14. So we have the case that is less than 6 or bigger than or equal to 14. Yeah, same thing here. We're just trying to isolate the absolute value, minus 7 on both sides. Notice now we have absolute value of this expression is less than negative 3, but absolute value is non-negative, so it cannot be negative. It cannot be less than a negative, so there's no solution for this case. And for this case, if I solve for absolute value again, I get that absolute value of 3 is bigger than negative 3, but the absolute value is bigger than or equal to 0, so certainly it's bigger than negative 3. So this is true for all real numbers, because this is always going to be bigger than a negative. So the solution here is the opposite of this one. The solution for part B is all real numbers. And if you have some specifications with this being 0, well, again, absolute value is always bigger than or equal to 0, so this is true for all x. And for this case, the absolute value for x plus 2 is bigger than 0. Well, one way of doing this is to kind of figure out where is, well, first of all, this thing can only be bigger than or equal to 0, so let's figure out where is equal to 0. So when this is equal to 0, either this is equal to 0 or this is equal to negative 0, but that's the same thing. So if I solve for this, I get that x is negative a half. So negative a half is the only place where it makes this expression equal to 0. And because we know that this expression is already bigger than or equal to 0, we simply take out the only place where it makes it equal to 0 is negative a half. So we take out that point, and everything else would be bigger than 0. And that's a little bit confusing, so I'll say that again. This absolute expression is always already, without anything, bigger than or equal to 0. And so to have that this is bigger than 0, well, this is already true, except the only case where this is not true is when this expression is exactly equal to 0. And so we make it equal to 0, and then we throw away that one point. And for this case, this absolute value can never be negative, so really the only case where this could even be true is when it's equal to 0, and that the only answer there is negative a half, just like we saw earlier. Another way of doing absolute value is to use the test point method, which means that, well, let's just solve for this first. Isolate the absolute value to get this is less than 11, and to solve the inequality, we can make it equal to 11. So absolute value of 3w plus 1 is equal to 11, so it's either 11 or negative 11. We solve those to get 10 over 3 and negative 4. So these are the two solutions that make it equal to 11. To figure out where it is less than 11, we can plug it in the number line. So we draw the number line, and we plug in these boundary points, the points that make it exactly 11. So those are these points that make it exactly 11. And then we simply use those points to divide the number line into 3 intervals. The first interval is less than that. The second interval is bigger than this point but less than this point. The third interval is bigger than this point. So now that we divide them into 3 intervals, we can plug in points from each of the interval and see whether it makes the inequality true. So if I plug in, say, negative 5, any point in this interval will work. Pick a negative 5. If I plug it in, I get that it's false. But if I plug in 0 in here, I get that this is true. If I plug in something over here, say 4, I get that it's false. So that means the only place where this is true is this interval, and that must be the solution. So this is another way of doing inequality, to solve for equality and then use test points. So again, we saw earlier that absolute value is used to denote distance. In particular, the absolute value of c minus d is the distance between c and d. So for example, the absolute value of negative 2 minus 3 is 5, which means that the distance between negative 2 and 3 is 5, which actually is correct. So let's kind of write an absolute value inequality to represent the following phrases. R real number is x whose distance from 0 is greater than 5, and R real number x whose distance from negative 7 is less than 3. So again, the distance between x and 0, x minus 0 absolute value is greater than 5, so which means that absolute value of x is bigger than 5, which means that x is either less than negative 5 or bigger than 5. The distance between x and negative 7, it means you just say absolute value of x minus negative 7 is less than 3. Simplifying, you have absolute value of x plus 7 is less than 3. And again, this is we can do the same trick we saw earlier, where we use test points, and then we get that this is the solution set. So you can check that if I do this out, I get this answer. So here's an example. Latoya measured a certain compound on a scale in chemistry lab at school. She measured 8 grams of the compound, but the scale is only accurate up to to plus or minus 0.1 gram. We want to write an absolute value inequality to express an interval for the true mass of x of the compound that she measured. And so because the scale is only accurate to plus or minus 0.1 gram, the true mass x of the compound may be off by 0.1 above or below what was being measured. And so the way we write this is we say that the distance between the true mass and the measure mass, 8.0. So again, absolute value of x minus 8.0. The distance between the true mass and the measure mass is less than or equal to 0.1. And if you solve this, you get that x must be between 7.9 and 8.1. Again, here's 8.0, which is the center. If the distance between x and this center is less than or equal to 0.1, means that it has to be between 7.9 and 8.1. Okay, 2.1, linear equation in two variables. Here's the rectangular coordinate system. We have the y-axis going up and down, the x-axis going left and right. Positive x is on the right side here, negative x is on the left. Positive y points up, negative y points down. We divide up the plane into four quadrants: quadrant 1, 2, 3, and 4. We go counterclockwise. And so if we look at each point, we want to know where it is. So for example, 4, 1 means that x is 4, y is 1. So for example, you go x is 4, y is 1. Negative 3, 4. Negative 3 is x, 4 is y. So you get that point. And so we always look at the x first and then the y as another one. And again, once you have these, you know which quadrant is in. The only thing that I want to point out is that if you're on the axis, it's not considered any of the quadrant. So 0, 3, for example, is on the y-axis, and then negative 4, 0 is on the x-axis. So these 2 points are not on any quadrant. And you're welcome to look at the other ones to make sure that you understand how this coordinate system works. Okay, let's talk about linear equation of two variables. A linear equation of two variables is an equation of this form: ax plus by equals c, where a, b, and c are constants, x and y are variables. This form is also called standard form. And a solution to a linear equation in two variables is an ordered pair x comma y that makes the equation a true statement. So for example, here's a linear equation. If I want to know whether these are a solution, I just plug it in and make sure it works. So plug in negative 4, 0, for example. I get that 8 is equal to 8, so that's true. So that is a solution. Plug in 2, negative 4, I get that's false, so that's not a solution. If I plug in 1 and 10 over 3, I get that is true, so that is a solution. We want to look at the graph of an equation in two variables. So to graph an equation of two variables, it means that we graph all the ordered pair solution of the equation. So all the ordered pairs needs to be graphed. So let's graph this one. So let's pick out some points and plug it in and see if we can find some solutions. It doesn't really matter whether you pick x or y, but when once you pick one, the other one is determined. So if x is 0, for example, then we can figure out that y must be 3. When x is 0, y must be 3. But if y is 2, I plug it in for y is 2, and I solve for x, and I get that x must be 5 over 3. And finally, if x is 5, I plug in 5 for x, I solve for y, I get y must be 0. So if we do that, then we can find 3 points that are a solution to this equation. And then I guess I'm missing a slide here, and then when you plot the points, as we see later, this graph will give you a straight line. And so once we plot those 3 points, we can draw a line connecting it. So we'll come back to this example a bit later. And I probably will also add in another slide after this. I think I'm missing some more information for this example. So please check your notes for this. Let's look at x-intercepts and y-intercept. The x-intercept is the place where the line crosses the x-axis, and the y-intercept is the place where the line crosses the y-axis. And it doesn't have to be a line, it could be also any other graph or equation. So to find the x-intercept, we have to make y be 0, because the x-intercept is where y is 0, and we solve for x in that case. To find the y-intercept, we make x be 0, and then we solve the equation for y. So for example, let's find the x and y-intercept of this equation. So to find the x-intercept, let's make y 0. If y is 0, you plug in y is 0, x is 4. So this is the x-intercept, 4, 0. To find y-intercept, you make x be 0 and then solve for y to get 2. The y-intercept is then 0, 2. And then we plot the points that we found that are solution, and then we connect the dots to get our straight line. So again, this is what I was missing in the previous example. Yeah, we'll talk more about this these equation being why it has this graph in the next week video. So again, a linear equation has the form ax plus by equals c, where a, b are not both 0. If a, b are both 0, then this equation won't make sense if c is non-zero. But if either a or b is 0, but not both, then we have a horizontal or vertical line. So for example, if we have that y is 0, in other words, if b is 0, then we have that we have a vertical line, and if we have that a is 0, then we have a horizontal line. So let's kind of see an example. In particular, a vertical line has the equation x is k. A horizontal line has the equation y is k. Okay, so let's graph this equation. X is equal to 6. So this is the case where it's a special case where it's either horizontal or vertical. So let's see which one it is. So this is the vertical case, and one way to see this is to kind of look at the graph. X is always 6. Well, whatever y is, x is always 6. So I plot that condition. X is always 6, whatever y is. So you connect the dots, you get that this is a vertical line. Another case, if you have that y is equal to a constant, if you divide by 4, you get that y is equal to a constant. This is a horizontal line. And that's because, again, if I make a table of values, solutions of this equation, whatever x is, y is always negative 7 over 4. So y is always negative 7 over 4. X can be anything at once. These are the solutions to this equation. And therefore, in this case, we see that it's a horizontal line. Let's talk about the slope of a line. So let's look at the set of stairs and this ramp, and see if we can understand the idea of a slope. So notice that on the stairs, if I move horizontally 4 units, I move up 3 units. On the ramp, if I go horizontally 18 feet, I move up 3 feet. And so the question here is, which one is steeper? Which one has a bigger incline? Well, notice that both of them goes up by 3 feet vertically, but it takes the ramp a lot longer it takes the ramp 18 feet to go up 3 feet. The stairs only take 4 feet, so that means that the stair is steeper. So how do you make this precise? Well, we can look at the change in y, the vertical change or the rise, and you divide by the change in x or the run, and see, and this number is a measure of how steep the line is. So again, change in y, the change in y in the vertical direction, divided by the change in x. So the rise divided by the run, that's a measure of the steepness of the line, and we call that the slope. So for example, the previous example, the change in y, the rise is 3, the run is 4, so it's 3 over 4. That's the slope. But for the ramp, the change in y is 3, but you divide by 18, so 3 over 18 is 1/6. So 3 over 4 is bigger than 1/6. Therefore, the stairs has a bigger slope than the ramp. If you have 2 points on a line, we can find the slope by using the slope formula. So suppose you have a line going through the points x1, y1, x2, y2. The equation for the slope passing to those 2 points is change in y is take y2 minus y1. That's the vertical change, divided by the run, which is the x2 minus x1. So change in y over change in x. So this is the equation for slope. And it doesn't matter which one you call x1, y1, x2, y2. I can switch the order of the points as long as I'm consistent that I take one y, subtract the other, and then I must take that first x and subtract the other. If I do that consistently, then it doesn't matter the order. We gotta make sure that the bottom is non-zero, because otherwise you can't divide by 0. So we see that in a moment. So here's the picture view of this equation. You look at the change in y, divide by the change in x. That's the definition of a slope. Change in y is y2 minus y1. and the change in x is x2 minus x1. So that's why we have that equation. So let's find the slope between these 2 points. So let's call this one x1, y1, x2, y2. And again, it doesn't matter. I can switch the order here, and it doesn't matter. The answer will be the same. And so y2 minus y1 is 2 minus negative 1. So you gotta be careful that you're minusing a negative 1. So 2 minus negative 1, 7 minus 1. So if I simplify that, I get 3 divided by 6, which is 1/2. So the slope of that line is 1/2. So here it is. Again, rise over run. So rise is 3 divided by run is 6. So 3 over 6 is 1/2. Okay, so when you apply the slope formula, a slope can be positive, negative, or 0, or undefined. So let's look at some cases. If the slope is positive, that means that the line is going this way. In other words, if I go from left to right, then you're going uphill. So as I go left to right, I'm going uphill. And then if the slope is negative, then as I go from left to right, I'm going downhill. So that's a negative slope. And then when something has 0 slope, if I go left to right, then I'm not changing. The vertical direction is not changing. That means, for example, if I'm walking on the floor, then there's no slope. And then undefined slope is when the slope is vertical. In other words, it's an infinite slope, right? If the slope is imagine if this is a hill, this is a very difficult hill to walk up because it's straight vertical. So this is called an undefined slope. So make sure you understand the geometry of these 4 cases. If I want to find the slope of these 2 points, again, y2 minus y1, x2 minus x1, I get that negative 6 over 0. I can't divide by 0, so this slope is undefined. And so that means that if you plot the points, these 2 points give you a vertical line. A vertical line has no slope. So this slope is undefined. But if I do this one, I use the formula again, and I get that 0 divided by negative 4, and 0 divided by negative 4 is 0. Notice in the previous case, you have negative 6 divided by 0. You can't divide by 0, but you can have 0 divided by something else. So this is 0, so the slope is 0, meaning that this line is horizontal. What does it mean for 2 lines to be parallel? 2 lines are parallel if the slope is exactly the same. So the rise and the run is the same, so that if the lines are different, these 2 lines being parallel would not intersect. 2 lines are perpendicular if they intersect, and they intersect at the right angle. This is 90 degrees. And so it turns out that there's a relationship here. So if this is rise is 7, run is negative 2, then to get the other slope, you must have you must kind of like flip it. So you have to instead of going up 7, now you have to go horizontal 7, and instead of going left or right by 2, you have to go up and down 2. So the vertical direction becomes the horizontal direction, and the horizontal direction becomes vertical direction. If I flip those, then I get I see that this slope negative 7/2, and this slope is 2/2, and so the pattern here is that these slopes are negative reciprocal of each other. So if M1 and M2 represent slopes that are parallel, then the slopes are the same. But if the 2 slopes represent slopes that are perpendicular, then one is the negative reciprocal of the other one. Or in other words, when I multiply them, I get negative 1. So let's try some example. If you have a line of slope negative 5, then the slope of a line that's parallel to this line has slope equal to it, which is also negative 5, same slope. But if you have a slope of a line that's perpendicular to this given line, then the slope of that line must be the negative reciprocal of this line. So the negative reciprocal of negative 5 is positive 1 over 5. So you just negate it, and then you flip the fraction. So that's another example. If the slope of a line is negative 4 over 3, the slope parallel to that would have the same slope, negative 4 over 3. But the slope of a line that's perpendicular to that would have slope 3 over 4. Positive 3 over 4. Negate, and then flip. Okay, that's it for this week. Yeah, so if hopefully, I know sometimes we go a little bit fast here in this video, but feel free to pause, rewind, and thanks for watching.